Okay, you should know how to solve trigonometric equations, and now we move on to, since you've been introduced to the identities, you've been introduced to reciprocal functions, why not attempt to solve them with reciprocal functions? So not to fear reciprocal functions, the signs of the reciprocal functions will be the same in the quadrants of the unit circle, and you can just reciprocate them back to be able to deal with them. So as in, like, you know that secant theta is basically 1 over cos theta. So deal with them exactly the same. Now, if I want to solve this, doesn't seem clear how it would be obvious. I am missing a 5 here. So when I'm trying to solve this, I would preferably want to look at the identities, because when I say tan, when I say secant, I know that there's an identity between them, but I can't use secant squared. So I can't replace the secant, I have to replace the tan squared. So I know that tan squared theta, so just rearranging the second one, is equal to secant squared theta minus 1. So what I'm going to do is just replace this tan squared with this expression. So I'm left with 3 brackets secant squared theta minus 1 minus 5 secant theta plus 1 equals to 0. Expand and simplify. So once you do that, you will get 3 secant squared theta minus 5 secant squared, and then plus 1. Okay, so this will expand to 3, negative 3, and then, not plus 1, minus 2. Rookie mistake. Okay. So I have this expression, which by now, if you've seen the previous videos where I solved trigonometric equations, you should recognize, well, this is a quadratic in terms of secant. And if you want, you can replace the secant with a u and then solve it as a quadratic, but I'm going to avoid that. There's enough about this that I've done before. So I'm not going to go into the details about how to find the two values. This can be done without a calculator, by the way, all until the end of the question. This can be done without a calculator. So I can use you could use a quadratic formula to find the values, and with a quadratic formula, it's going to end up giving you is that secant theta is equal to 2, or secant theta is equal to negative 1 over 3. So all can be done without a calculator. So once you have that, then you want to solve it, but you have no idea how secant theta behaves as a graph, for example, or in terms of values. So let's just replace it back with 1 over cos theta. So same thing here, 1 over cos theta. And that's equal to 2, that's equal to negative 1 over 3. And what we're going to do is we're going to reciprocate on both sides. So I'm going to reciprocate here, reciprocate here. If you want, you could like put this over 1 and cross multiply, same thing here, and just make cos theta the subject. Any algebraic method would be valid, and this will give you 1 over 2. Reciprocate this as well, and that's going to give you negative 3. Don't change the sign stays the same. Now, this will be, so no valid answer. There is no such theta that will give you a negative 3. The maximum cos theta could get to, just cos theta on its own, is a maximum is 1 and negative 1 is the minimum. So we're left with this, and you need to take the inverse of that. Again, this should be easy to do, and that will be pi over 3. I forgot to mention, we are dealing with theta between 0 and 2 pi. So this is one of the exact ratios that you should know. But we are between we're from 0 to 2 pi. So when I have this quadrant, my cos theta, remember this is where you go always, this is positive. cos theta is positive, it means I'm looking at the first quadrant and I'm looking at the fourth quadrant. So the first and the fourth. And this is my reference angle or the acute angle. It's already in the first, so I have my first. But to get the fourth quadrant, I need to go 2 pi minus pi over 3, and that's going to give me 5 pi over 3. And you can check your answer by substituting back in and see if you get the, if you substitute pi over 3, you should get 0, and if you substitute 5 pi over 3, you should get 0. So these are your two solutions.